Today we are going to talk about how to write a binary search program in Java. Binary search is used to find an element in a sorted list. It can be a sorted list of integers, strings, or anything. Only requirement is that it has to be a sorted list, either descending or ascending. So let's use the Eclipse IDE to create a new project to write the program. Let me create a new Java project. Let's name it binary search, and let's create a new class. Let's name it as binary search itself, binary search, and let's give the package name sample. Okay, now let's talk about the basic algorithm of binary search. Binary search works on a divide and conquer method. Let's take the example of a sorted integer array. Now let's sort an array. So 1, 3, 5, 7, 10, 12, 15, 19. Now let's take use a value, a variable x to denote the value which we are trying to find. Let's try to find the value 12. Now if you see the sorted array, the value only exists. So let's go through the algorithm. So to start, before starting the iteration, we need two indexes. One is the start, which will be 0 during start during as the initial value, and end, which is the which is the length of the array. So it will be length of the array minus 1. So currently the length of the array is 1, 2, 3, 4, 5, 6, 7, 8, and then the end will be length of the array minus 1, which will be 7. Now let's go to the iteration and see what happens to these indexes. So iteration 1. So to start, starting point of every iteration, we need to find the value of the value of the middle. So the value of the middle will be start minus so n minus start and divide by 2. So for the first iteration, the value will be start is 0, end is 7, 7 minus 0, 7 divided by 2 is 3. So now the next question is whether the value of the index 3 matches the value of x. Value of index 3 is 0, 1, 2, 3 is 7, and doesn't match with the value of x. Now what's the now the next question is whether it's greater than or less than the value of x, and answer is it is less than the value of x. So at that point, if the value is less than that, then we only need to worry about the values above the index 3. Anything below index 3, we are sure that the value x12 won't be there because it is in ascending order. So at that point, we will have a new start value, which is mid plus 1, which is 4, and n will remain as it is. Now let's go to the next iteration. 2. Now the mid value is the same thing. I'll just do a copy paste. And if the start is 4 and end is 7, 7 minus 4 is 3, 3 divided by 2 is 1. Now that's not the one we are looking for. We are looking for between 10 and 19. It will be either 12 or 15. So the missing part is we had to add the starting point also, which is 4. So start plus n minus start divided by 2 is equal, and then the value will be start is 4, and n minus start divided by 2 is 1, then the final value will be 5. So the same thing need to be applied to the first iteration also. So since for the first iteration, the start value will be is 0, so there won't be any, it won't make any difference. Now the now we have a new mid value. Now the question is whether the value of the index 5 matches with the value of x, and the answer is true. That means we found the element, we found the value which we are looking for, and we can return back true from the and we found the element we are looking for. Now let's take the next scenario, which is the element we won't find the value which we are looking for. Let's take the let's take the x value as 4. And now 4 doesn't exist in the sorted array, and let's go through each of the iteration one by one. Okay, so now let's take this iteration. Let's copy the iteration 1. Okay, now in the first iteration, the same thing applies. We have the start and index, both are same. And iteration 1, we calculate the mid value 3. Now here is the one difference. So here the value which we are looking for, which is 4, which is less than 7. So at that point, if the value which we are looking for is less than the mid value, then we change the end index rather than the start index. So in this case, the start index will remain the 0, and the end index will be mid minus 1, which will be 2. Okay, now next we will go to the next iteration again. So iteration 2, the same thing applies. Mid, I'll copy paste. Mid will be start plus n minus start divided by 2. Here the start is still 0, end is 2. 2 minus 0 divided by 2 is 1, so it will be mid value will be 1. Now the value at the index 1 is 3. Is 3 less than or greater than 4? And the answer is 3 is less than 4. So in that case, we again do a in that case we change the start value, which is mid plus 1, which is, and then the start value will be 1 plus 1, which is 2. N will remain the 2. Now if you see, both start and end will remain as it is, will be the same, but we'll continue the next iteration one more time. Iteration 3. In the case, we have a new mid value. Let me copy paste it. In this case, the new mid value is the start is 2, and n minus start is 2 minus 2 divided is 0. 0 divided by 2 is 0. That means the new mid value is again 2. In this case, what happens is that we have again the the value at the index 2 is 5. At that point, what we do is the start remain the same. Start will remain the same, but the end will be mid minus 1, which is 2 minus 1, which is 1. At this point, what happens is that the start is more than the end. At this point, we can stop the iteration and confirm that the value which we are looking for doesn't exist in the sorted array. So that will be the end of this iteration. And whenever the start is greater than end, we can stop this. So so let's go and write the actual program. So let's write it on the first. Let's write it on the main class. Public static void main string okay. Now let's write the method public static boolean binary search, and we have two parameters. One is the array, sort array, and the value which we are looking for, and by default we will return false. Okay, now let's write the program. As I mentioned previously, we need two indexes. One is the start, which is the starting value is 0, and we have an end value which is sorter array dot dot length. Now we'll write the while loop. So we use the while loop for the iteration. So while and the iteration will be whether we can continue the iteration until start is less than whether when the start is greater than until we can start that means in the moment the start is greater than end, we can stop it. That means we can continue the while loop until start is greater than or less than end. And okay, now the first thing is we have to also let's initialize the mid value, which is by default it can set to 0, but we will be initializing every the mid value every time during the while loop. Mid value is start plus n minus start divided by 2. Okay, now we have this mid value. Now if now the first question is if sorted array mid is equal to x. What that means is that we can immediately return true. This is the only chance where we will return true. Otherwise, else if I'll just copy paste it. Sorted array dash mid is greater than sorted, or let's look at the less than scenario. Less than x. That means we'll if the sorted is then we will reset the start is equal to mid plus 1. Else now there's only one more scenario, that is sorted this is greater than this. That means end equals mid minus 1. Okay, if so mid minus 1. So this will so if you look at this program, if you look at this thing, we have we start with x is equal to 0, start equals 0, end is equal to 7, which is same as that start equals 0, end is equal to sorted at length. And we every time during the mid we will set the start we'll set the mid, which is start plus n minus start divided by 2. And we have this we have the if loop check, which is if it is same as x, that means we'll return a true. Otherwise we will if the sorted array mid is less than x, that means it is if it is less than x, then that means we will return back, we'll set the start value as mid plus 1, and otherwise we'll set the end value as mid minus 1 and return false. Now let's test it out the use case. So int let's create an integer array, sorted array. We can use the same value which is we defined on the top. Okay, and we will do a binary search. Let's print system dot out dot println print sorted array and value you're looking for is 12. Sorry, my mistake. Binary search. Okay, and let's run this program. True. Let's check the next one more use case. Let's do 4. Okay, so that concludes the session for how to write a binary search program in Java. Thank you guys.